Um, Hello. Yeah, yes. What happened? Hey guys, good morning. Am I audible? Give a thumbs up if you can hear me properly. Okay, nice. Let's wait for others, okay? Still a lot of people are yet to join, so let's wait for them. Okay, so instead of waiting for others, let me give a quick intro and let me tell you what we can expect in today's session. Okay, fine, right? I'm Ajay Muturaj, and I'll be presenting today's session with my fellow co-host Pranesh. We are from Electronics Club. Yeah. So as you can see, the title of today's session is "Probing with WalkP." As the name suggests, we'll be working on WalkP. So more on it later. Okay. So we'll be discussing about WalkP in detail later. Okay. So first, let's look into the table of content to know about what we'll be dealing with today. So as you can see, we will be covering these topics in today's session. So look forward to it. Okay, so Let's get on with it, okay? So, how many of you know or have heard about ESP32? You can raise your hands. Okay, nice, nice. More participants. Okay, okay. Some of you have heard about ESP32. Nice to hear about it. So, let me give a brief introduction of what ESP32 is. Okay, so it is a very popular microcontroller developed by a IC design company called Espressive System. So, its main advantage over the other microcontrollers is its inbuilt Wi-Fi and Bluetooth functionality. So, you can go through the definition over here. Okay, let me explain what an SoC is. Okay, SoC stands for System on Chip. Okay, so it means like a whole electronic system being on a single chip, like this. This is an SoC. Okay, okay. So hope everyone went through with the definition. So it's not very important to remember these definitions. Okay, you just have to get the feel of what you're going to do. That's more important. Okay. Okay. So next we will look into the development board that we will be working with in WalkFi. So the development board is called ASP32 DevKit. So yeah, you can go through the definition again. Okay, I will explain what a development board is first. Okay, so it is just a PCB or printed circuit board on which the microcontrollers and other components are placed for making it easier to work with the microcontroller on which it is based on. Yeah, you can go through the definition. Like it is just a PCB on which the microcontroller is placed, and it is mostly used for prototyping. Like before making any major projects, you need to learn how to use the microcontroller, right? So you use these development boards basically for learning how to use the microcontroller. So hope you guys went through with the definition. We'll go on to the next slide. So yeah, these are the various components that are used in the ESP32 dev kit. Let's go in a clockwise direction, starting from the microcontroller. Okay, so this is the microcontroller over here. It is called the ESP Broom 32. This particular version of the microcontroller is called ESP Broom 32, which is used in ESP32 dev kit. It is part of the ESP32 ecosystem. Okay. Okay, so I'll also give an example of like what else microcontroller is available for ESP32. Like the previous year, Electronics Club made a development board based on ESP32 S3, like, which is the most powerful ESP32 microcontroller out there. Okay, so ESP32 S3 is another such microcontroller which you can use in your projects. Okay, so next we'll talk about IO pins. So IO pins or input output pins. So they are used for giving input or getting output from the microcontroller. As simple as that. Okay. Okay. So next is the LED. Okay. So this is the LED which is attached to the GPIO2. So GPIO here stands for General Purpose Input and Output. So just to, to say it simply, just think of it as we can make the LED, this LED glow by changing the state of pin 2. Okay, pin 2 is for LED, this LED. So if we change the state of pin 2 to high, this LED will glow. Yeah. So next we will discuss about USB UART bridge. So this is used to convert the data we get from micro USB and convert it into a serial data, which is fed it to the microcontroller, or vice versa, or the data coming out of the microcontroller to micro USB. So this helps in the conversion of data. Okay, it is very important. Next, we have the boot or flash button. So boot button, they are used when we want to load our program to the memory of microcontroller. Okay. So next comes the micro USB. Uh, it is used to connect our laptop or PC to the development board for programming it, or just for giving power supply to it. You can do both. Okay, both at the same time also. You can connect it for giving the program into writing code into it, or also for giving power supply to it. Next comes the enable button. Okay. So enable button is also called the reset button. It resets the program and the program runs from the starting. The execution of the program goes from the starting and it starts executing from the first line. So next comes the 3.3 volt regulator. Okay. Yeah, I'll repeat the USB UART bridge. Okay. Okay. Fine. Fine. So next comes the 3.3 volt regulator. ESP32 works on a 3.3 volt. Uh, so it works on 3.3 volt. Okay. So the regulator is very important to prevent damage to the microcontroller. So everything here works on 3.3 volts. Like in Arduino Uno, it was mostly working on 5 volts, right? So it works on a different basis. Everything works here in 3.3 volts. So it is very necessary to regulate the voltage. Finally, we have the power LED. This helps us to know if the board is getting enough power input. Okay, so I'll look at doubts. If you have any doubts, you can write in the chat box. Yeah, I'll explain USB to UART bridge. Like the data that like microcontroller needs to get serial data. It can't read uh, like the data coming from the micro USB directly. So we need to convert the data into serial data. You will learn more about UART in the next session. Okay, so don't worry about it. You will learn about UART in the next session. And IO pins are yeah, GPIO means like you can use it for any purpose. Input output, like all the pins are called in IO pins. Like even the power pins, ground pins, they are called IO pins. But GPIO pins, the excluding the we'll learn about what GPIO pins are. Okay, there is a slide for it. I'll make sure you get what GPIO pins are. Yeah, so this is an alternative to Arduino. This as per I prefer it more than Arduino. Okay. Uh, yeah. So yeah, I've moving on. Okay, so I will show you how the PCB design of ESP32 looks like and what you can expect to learn in the PCB designing sessions. Okay, it's a very cool thing. Okay, I open the link. Okay, so this is how it looks after you've done all the routing and stuff, which you'll be learning in the PCB design sessions. So don't worry about it. Okay, let me hide this. This will show the connections, every connection. Okay, so I'll show you the 3D view, how it looks. So this is how it looks. Okay. I'll give you the link if you want to see how it looks, and if you want to work something out with it, you can. Okay, I'll provide you the link later. So yeah, So you might ask, why ESP32 and why not any other microcontroller? Right. So we'll be comparing ESP32 with Arduino Uno. So Arduino Uno is like the one of the most popular microcontrollers out there. So it is usually taken as a base to compare other microcontrollers with. So yeah, we'll be comparing these two. So the processor. One of the major reason for selecting ESP32 over Arduino Uno is its powerful dual-core processor with a clock speed of 240 megahertz. As compared to Arduino Uno's, uh, it has a single processor and clock speed of 16 megahertz. So it's much slower. Okay. So if you want to have complex programs running, ESP32 is the obviously better choice. So next, the most important reason for selecting ESP32 over Arduino is its built-in Wi-Fi and Bluetooth capabilities. So if we were to use any Arduino board, we will have to connect external modules for Bluetooth and Wi-Fi. Siddharth, you will know more about my PCB designing in the upcoming sessions, so don't worry about it. Okay. So, uh, so the growing so ESP32 it has a growing community, while Arduino has a well-established community. So, since Arduino is there in the market for a longer time, it has a bigger community, and well-established tutorial videos are available for it. And ASP32 was made a little much later, okay, like in the early 2016s, I think it was made. So, due to its features, it is growing in popularity and user base at a very fast rate. So when you will dive deep and learn uh, and when you dive deep and learn more about microcontrollers and electronics in general, you will know why a community is needed in general. Okay. Okay. So this is an ESP32 function block diagram. I don't need to know about this, but I'll just give a brief introduction of what it is. Okay. So this function block diagram is just a graphical representation of the elements of a complex system. Like the complex system over here is a microcontroller. Okay, like ASP32 is a it is the function block diagram of ASP32. It is not at all important. Okay, okay, so this is so relatable to me. Like I was like a hardcore follower of Arduino. Okay, and worked on it for like almost 2 years. Okay, so but after using ESP32, I switched my guru. Okay, so now I preach about ESP32 everywhere, literally everywhere. Okay, like even right now I'm preaching about ESP32. So yeah, moving on, moving on. So you might ask, where is it used? So due to its Wi-Fi and Bluetooth capabilities, this is mostly used in IoT projects. So you might ask what an IoT is, right? So IoT stands for Internet of Things. So I'll explain what an IoT is. Okay. Uh, it refers to the integration of internet connectivity into electronic devices, allowing them to interact with each other. So in more simpler words, you can say that helps in interconnecting everyday objects and enable them to communicate over the internet. Okay, so next I found and compiled some interesting projects made using ESP32. Okay, so are your doubts being cleared? Hopefully, yeah. So yeah, Okay, so the first project helps us to keep track of prices of Bitcoin. Okay, and also keeping track of percentage change compared to the previous day. So it's called the Bitcoin tracker. It's a very interesting project. Uh, yeah. So see, you can see the prices change, and if there is a positive change, the green LED will glow, or else the red LED will glow if it's a negative change. So next is a movie. That movie can be watched using OLED display. This OLED display can be used to watch movies. Okay. The movies are stored in this SD card over here. These are just some interesting projects that I looked over on the internet that you can take inspiration from and work on later. Okay. So yeah, this is how it will look. Pretty cool, right? So in the third project, we have a security system with four cameras. So these cameras are used to keep watch like a basic security system. We can use it to keep watch on our house. Yeah, so we can access these cameras remotely from anywhere. That's the good thing about it. You can remotely access these from anywhere using just ESP32 and internet connection. Okay, next, we have the smart doorbell. Uh, So, like whenever someone is coming and presses the doorbell, it will take a picture of the person who is at the door, and it will send to the owner who can remotely open the door. So yeah, in this project, they have used two methods of entry, like either using a RFID tag or entering the pin. Like RFID tag, I mean like Uh, the our institute's ID card also uses RFID tag. So if you are wondering, many institutes use RFID, and it also keeps a log of the data. So in the next project, they accessed radio stations. Okay, they can play music. See, the interface is also looking good. Yeah, so they can access radio stations and play music. They are using internet connectivity and to play this music. And now you can't hear the audio, but yeah, they are playing music. Okay. Okay, so this is a very interesting project. It is a portable surveillance robot. Okay, the movement as well as the camera can be controlled and accessed from your device, as you can see. Okay, so another interesting project. So this is a Nintendo emulator made out of ESP32. The data, the games and progress and stuff are stored in the SD card. Yeah, so we can play games like Super Mario and stuff. Yeah, so it's a great treat for the gamers. This is the SD card slot reader, SD card reader. Yeah, so in this project, they are running OpenCV. So it is very hard to run OpenCV. So it requires a, a good enough processor to run OpenCV. OpenCV, like it's computer vision. Okay, basically computer vision. It provides this system is called canny edge detection. Okay, it helps in detecting edges, as you can see. So in the next project, it helps in counting large number of objects. As you can see, yeah, it also uses canny edge detection for counting. So see, there will be six cards, and the output on the screen on the left will be six. Okay, six. Yeah. The last project, this project helps in detecting and also decoding the QR codes. It can even decode complex QR codes like one below. Yeah, so these are some very interesting projects that I looked on the internet, which is feasible with ESP32. So you can take inspiration from these and make your own projects, right? So how did you like them? Okay, nice, nice. Okay, let's finally get started with it. Okay, like yeah. So ESP32 boards can be programmed in the same way we program Arduino boards. So there isn't you don't have to learn like if you already know programming Arduino, you can program ESP32. You don't need to learn a lot of extra things. Okay, so that's a good thing, right? Okay, so so before you start making any project, you need to look at pinouts of the board. Okay, so you need to look at the pinout. Like we are using the ESP32 dev kit, so this is the pinout of this board. So we are using like see these are the different like pins and like every pin is a GPIO pin except the ground 3.3 volt ground and V input. This V input is used to give power supply with battery. Okay, or else you can directly connect a laptop to the ASP32 using micro USB cable and give a power supply to it. Okay, so this is a lot of things. You don't have to remember everything. We will talk about SCL and SDA. Okay, SCL and SDA specifically in the next session. Okay, so look forward to it. We'll talk about it in detail. So yeah, so the important I've been like talking about connecting to Wi-Fi and Bluetooth for a long time. So let's learn how to actually connect our ESP32 to Wi-Fi. Okay, so there are basically uh, okay. So let me read the chat. Okay, Satvik is asking, is ESP32 much more costlier than the Arduino Uno? No, the price difference is almost very negligible, right? Like 100, 200 rupees at max. They come at very similar prices. So yeah, that's the good part of it. Like the price is also like not that different from Arduino Uno. So yeah, let me explain these architectures. Like there are basically two ways to connect our ESP32 to Wi-Fi. Okay. So let me explain the first method, which is to connect all the devices, including our ESP32, to a router. Okay. So this is the router. This acts as the access point, and the other devices which are connected to this router are called station. Okay. Remember the station term. Okay. We will use this. They can also be called clients. Okay. Like yeah. The second method is to make the ESP32 the access point to which other stations or other devices are connected to. Okay, so ASP32 acts as the access point over here, but we'll be majorly using this architecture to connect our ESP32. While working with WOCP, we'll be using this. Okay, this architecture. So yeah, let's finally do WOCP. So you might want to know what a WOCP is, right? So it's the uh, title of today's session also. Yeah, so you might be wondering what WOCP is. So Walkme is a simulation software which is similar to Tinkercad. Okay, I personally prefer Walkme a little more because it can contain many other microcontrollers other than Arduino Uno. So, before we jump to Walkme, I just had a small suggestion to people who are watching and working on the same laptop or PC. So you can keep the screen arranged like this. This will help you in writing codes. Like I won't be doing much connections over here. So as you can see, that is no connection. Okay, we are not going to be connecting to it to anything. So you can keep the screens like this. So you can zoom in also to make the code more visible, and it will help you to write the code faster. And also, if you did any mistake, you can cross check from my code. Okay. So yeah, definitely keep the screens like this. Okay. So yeah, let's jump into Walkme. Just open a new tab and search walkme.com. So signing up is not necessary, but I would recommend you to sign up. It's a very simple process. You already have a Google account stored. So yeah, let me log out and sign up. So yeah, this will be your screen. Just sign up, Google. So signing up is necessary if you want to store your projects. Like if I click here, I can see my projects. So are you all in? Have you all opened a Walkme? Yeah. So let me introduce the web page first. So here we can see some interesting projects over here. Some of the templates which we can use. So the most interesting part is this IoT project section, this joke machine. I wish, hopefully, if we have time, I will explore on it a little more. Okay, so if we have time, I'll explore. Okay, this is a very interesting project. So yeah, MicroPythons. This we will mostly be studying in Rust. We won't do anything about Rust, but see, the MicroPython will be taught in the fourth session, so look forward to it also. So yeah, we'll be coming into this part. Okay, so we can use multiple microcontrollers over here. When you click plus more options, you can see a long list of microcontrollers like the ESP32 S3, which I mentioned earlier while talking about our electronics club's development board, which they made by themselves. Yeah, so they use this ESP32 S3. But as I have introduced the dev kit, we'll be working on it. Okay. So yeah, so double click on it. You'll get this page open. So is everyone on the same page, or do I need to wait for someone? Okay, nice, nice, nice. So Pradeep, what do you want to know? Okay, so I'll open Walkme again. So if we go down, there's a start from scratch section. So we'll be starting from scratch. Okay. Yeah. So from there, select ESP32. So you will see this page. Fine, right? So you might have a doubt since we are using a virtual ESP32. in a virtual environment. So, how can we connect it to Wi-Fi? Yeah, that's a very valid doubt. Like, before answering that, let's write a small program to scan for available Wi-Fi networks. Okay. The first line, so we have to include a library. We are going to include the Wi-Fi library. So libraries are predefined programs which we take use of uh, while writing programs to make it easier for us to write uh, programs. Like it has predefined functions and constants which we make use of in our program. So yeah, we use libraries in other programming languages also. So yeah, so in C++ we use hashtag include uh, to include the library in our program. So we'll be using multiple functions from here. So I'll explain you the functions as we go on with the program. Okay, fine, right? Okay, let me begin then. So first, let's do the setup portion. So serial begin. It doesn't matter. Okay, this value doesn't matter. You can keep it 9600. Any value. Okay, like 11520 is uh, it's like it's the baud rate. It is a large baud rate. Uh, it is not that important right now. Okay. Normally in Arduino Uno, like Arduino IDE, you need to change this baud rate at two places, like while writing the program as well as while seeing the serial monitor. But in simulation softwares, there is no such problem that occurs. So you need not worry about it. Okay. First, we will write this line, which will set the yeah, and keep make sure that F is capital. Okay, F is capital. Yeah. You might ask what this function does. So we talked about uh, ASP32 acting as a station, or we can make it act as an access point, right? So by default, it is in station mode only. But to introduce like how to we can change the mode, I have introduced this function called mode. We can change the mode like this will set the mode of the ASP32 to station mode. Okay, make sure that everything is capital over here. Okay, so there is already a serial print here. So we'll just put setup done over here. So we'll mainly be working in the void loop part. We'll be scanning again and again. So first we'll write a program line serial dot println and initialize just a line which will be displayed. It's just for aesthetic purposes. No such a requirement. Okay, so this line is important. Make sure F is capital again. So, what this function does is it initiates the scanning. It not only initiates the scanning, but we have created a variable called n, which is an integer. So this not only scans but also gives the number of networks it found. Okay. So let's assume there are five networks right now. Okay. Like right now, I have like okay. So there are four networks right now in mine visible. Let's assume there are five networks. Okay. So yeah, when will this be zero? When will n be zero? When there is no network available. So yeah, we just wrote if condition that if there is no n found, the output will get the printed output that we'll get in the serial monitor is no networks found. Okay, fine, right? Do you have any doubt? You can write it in the chat box. I'm looking at it. So we wrote the if portion. Let's write the else portion. So else, what does else signify here? If uh, there are some networks other than zero, like there are any networks found, the program will come in this portion. Okay, so I have I'm writing a loop. You might have learned for loop, right? You might have learned for loop anywhere, but it's like first we have initialized the value of I as zero. Then we wrote the exit condition when I is less than n, and plus I. This will increment the value of I in every time it completes the loop. The value of I will increase by one. Okay. Okay, so where two brackets? Okay. Okay. Thanks for pointing it out. Okay, let's write the code in the for loop. So we are assuming there are let's say five. Okay, so let's say we are getting uh, five networks. Okay, so the first like in programming language, you might have known that the number starts from zero, not from one. Okay, so if we have five elements, the numbering will be zero, one, two, three, four. Okay. Yeah. So can you repeat what is the use of a Wi-Fi STA, which is underscore STA? Okay. It is just to set the like we have ESP32 here. I explained in one of the slides that we can set ESP32 to access point or as a station, right? So this is used to set the ESP32 as a station, which we can use to connect to other routers. Okay, the router will act as access point, and this will act as station. This is not necessary actually. You can skip this, but I just introduced. So if later on if you want to make it as an access point, you can change it to AP underscore AP. So yeah, like I was saying, so the numbering starts from uh, zero, right? So but if you want to print like a list, the numbering should start from one. So yeah, we are just doing that. We'll just leave some space just while printing to make it look better. Next we'll print. We'll use another function. I'll explain now what this function does. Okay. Control C. Control V. Okay, we are using another function over here, RSSI. So yeah, you might be wanting to know like what is Wi-Fi.SSID. Have you heard about SSID while working with networks and stuff, like connecting to Wi-Fi networks. You might have heard this term SSID, right? Okay. So SSID stands for Service Set ID. Refers to the name of the network. Like I shouldn't be showing you this. Like MSPL over here, it is SSID. There are other names. Okay. So the RSSI, it refers to the Received Signal Strength Indicator. It stands for Received Signal Strength Indicator. Okay. So like there are different signal strengths being shown here, right? Shows these different signal strength. Yeah. Yeah. Wi-Fi. Name of Wi-Fi. Yeah. So yeah. So that's it. Let's write a delay. As there is a loop, it will continue going on and on. Let's write a small delay. Not that small. 10,000. Okay. So delay is in milliseconds. Okay. We are writing 10 seconds over here. And semicolon is very important. Make sure you have put semicolons everywhere. Okay. So uh, so this ESP32 is in a virtual environment. Okay. This is a virtual ESP32 in a virtual environment. It shouldn't technically be able to find any Wi-Fi unless let's run the program. Yeah, like name of Wi-Fi. Like okay, so that should be a semicolon. My bad. Should be a semicolon. My bad. Make sure to change it to semicolon. Okay, I put a comma instead. Should be a semicolon. Okay, so we are finding this. Okay, so it is detecting one network, which is called what we guessed. So you might have not expected this result, but let me explain. Okay, so the reason you are able to see this network is because Walkme provides a virtual access point by the name of Walkme guest. Okay, so if you like, if you have a real ESP32 and use it in a real life, you might find that you might find the other Wi-Fi networks that are available. Okay, so yeah, I hope you can buy one and use it IRL. Yeah. So we will be making use of walk we guessed. Okay, this is the SSID. We'll remember this and we'll make use of this in the next project, which we'll be working on. So are you done with it? Is everyone done with this? F capital, Satvik F capital. I mentioned it. F capital. F must be capital. Okay. So is everyone able to see the result? Give a thumbs up. Okay. 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 Nice. Okay. Yeah, there might be some issue while compiling. Even if you don't have any error, sometimes it takes a lot of time in compiling. Okay. Yeah, but it will work if the code is fine. Yeah. Okay. That's Aradhya. I'll explain what uh, print ln and print difference between print ln and print. Okay. Like while we simply print, it will not go on to the next line. Like while if we write print ln, it will go to the next line every time the content is showed in the serial monitor. It will go to the next line. So it stands for next line. Okay, just think of it as a new line. new line. Okay. So yeah, I'll explain why walkie guest is appearing. So right, so we are in a virtual environment, right? There shouldn't be any networks available in that virtual environment. But walkie provides you with this access point. It's a internal thing, okay? Walkie provides you with this access point which you can connect to. So if everyone is done with it, we can move on to how we can connect this ESP32 to the this walkie guest. Okay, nice, nice. But I don't think anyone's left. The number to the right is the strength, okay? It's just some random numbers. I mean, I they don't need to worry about this. It's just some random numbers. But normally, if you use it in real life, you will see the actual signal strength. Okay, as shown you, right? This strength, the power number of bars it is filled depends on this strength. Okay, fine, right? Nice, nice. Okay, I'll explain it the loop portion once again. So this function initiates the scan. Okay, this is what initiates the scan, and also returns. This function returns the number of what do you say? The number of networks it found during that scan. Okay, so we got the value of n. So this n, suppose n is 0, so it will enter this portion. Okay, so and it will print no networks found. But since there is one network available, it goes in the else portion. Okay, so it's we have assumed there are multiple what do you say multiple networks. Okay, so we wrote a loop which displays every network available to the ESP32. So the serial print, we have written I plus 1. We have started initially from 0, so it will increase until the value becomes 4. Okay, because let's assume we have 5 networks, so n will become 5. So I will satisfy this condition until it becomes 4. Okay. So 0, 1, 2, 3, 4. So this loop will be executed 4 times. But since the first number can't be, means while normally writing a list, we initially start from 1, right? So we have written I plus 1. So for aesthetic purposes, we left some space. It is not necessary. Uh, and then the SSID, this function helps to write the SSID at 0th place. Like 0th is the first place, okay? Like in programming languages, zero position is considered to be the first place, right? So yeah, this is the SSID of the first network. This gives the SSID of the RSSI of the first network, and we have printed everything. It will not scan Saket. It's just a virtual access point which is provided by Walkbee. Okay, this we can't scan external networks through it. So Wi-Fi RSSI refers to the signal strength. Okay, I'll get on with the next program, which is to connect to the Wi-Fi, which is Walkbee guest. Okay, everyone, you can open a uh, new tab with Walkbee. We have to include the library again. including the Wi-Fi library. So libraries are actually very important when you make complex projects. Everyone might use 10, 15, at least 10 libraries, 10, 15 libraries in a complex project. So yeah, you will learn the importance when you actually get your hands dirty with it. Okay. So yeah, before before getting to the setup part, uh, you know about string, right? Like a sequence of it's like a it is used to create a variable uh, which can contain sequence of characters. Okay, might have used it in. Okay, so Harshini, so the delay was necessary in the previous program because it wasn't necessary. It was like we we didn't want it to continuously scan it. Okay, so we put a delay to prevent continuous scanning. It is not necessary. Okay. Okay, so moving on. So this is the SSID we found. So by default, the password uh, for this walk we guest router. Let's assume it's a virtual router. Okay. So let's assume it's a virtual router. It's not a router. Okay. So so the default password for it is there is no password for it. So walk we didn't provide any password for it. So we can write an empty string as password. So yeah, you might ask why we have only written SSID, right? You can write anything. Let's assume I write XYZ. Okay. Okay, it will be hard for you to understand. You can write anything, okay? Just this value matters. Okay, so while setting it up, like the name suggests, setup, right? We are going to set up the Wi-Fi in the setup portion only. There is no requirement of loop portion. Okay, so like you don't need to delete comments. It is just a little uh, irritating for me. Yeah. So I'll write the first function which we are going to use to establish connection. Again, make sure that F is capital, which is very important. Okay. The serial dot begin. Next, let's say that it's connecting. Okay, so we are going to use a while loop here. Another function, Wi-Fi dot status. I'll explain what this line does in a second. And do remember that serial print is not actually important for connecting and doing anything except that it displays stuff. Okay, it helps us in identifying what the thing is doing. Right, doesn't change anything the ESP32 does with like connecting to Wi-Fi. We are connecting to Wi-Fi, right? So writing connecting here doesn't make it connect to Wi-Fi automatically. Yeah, I'll explain this code. Okay, let me write it. Okay, fine. So this line, okay, this is a very important line. Like uh, the Wi-Fi status, right? tells us about the current status of is it connected or not. Okay. So exclamation mark is equal to. If you might have used Python or even in C++, even if you have learned C or C++, you might know that this is equal to, this is used to show that not equal to sign. Okay, this is not equal to sign. So we are basically saying if Wi-Fi is not connected, right? This is a constant value. Uh, this this is a constant which comes from Wi-Fi library. So in the definition of library, I mentioned that we take functions and as well as constants from this library, right? So this is a constant value which is taken from the library. Yeah. So if Wi-Fi status is not connected, okay, then it will print dot. So since we have written ln, it will print a dot. It will come next line, print a dot. Next line, come print a dot. So yeah, we have put a delay so that I'll learn. I'll make you understand why we have put a delay over here. So yeah, next. I so when will it come out of the loop? When it is connected. Okay. So we will write connected. Yeah. Okay. So Wi-Fi dot begin like this is a important function to begin connection with the like with the Wi-Fi network. Like we have considered a virtual router, right? So it will start establishing connection with the virtual router. Wi-Fi dot begin. So its format is like we have to first put in the SSID, then password. So if you are using like this in real life with a real ESP32, you'll need to use your network's name and password. Fine, right? Okay, so you might know that every device in a network gets assigned a IP address, right? So okay, so if you don't know, every device in a network gets assigned its own IP address. So we'll find the IP address over here. So this is a function which helps us to find the IP address of the ESP32 in the local network. Yeah, void portion, it is not at all important. You can just skip it. Yeah, let's hope that the program is right. Fingers crossed. We compile. If you do have any doubt, put it in the chat box. Okay. Again, semicolon. It's fine. Yeah, in line 5, yeah, we could have done that. We could have done Satvik, yeah, you're right. But the second W will be small. WI both will be small. Yeah, so this is the local ESP this local IP address of this ESP32. Is everyone getting a good result? Is anyone facing an error? It is connected. On the top, you can see there is a message coming that Wi-Fi connected to walkie test. Okay, fine, fine. I'll explain the code. It's a very easy code. First, we began the connection using this begin function. It initiates the connection. Okay, so its format is like this only. The first portion will be SSID, and the second portion will be the password. Next we used this is for serial monitor. We have this baud rate can be anything. Let's say it's 9600. Then as we started our initiating our connection, let's say that let's print that it is connecting. Yeah, so the while statement, the Wi-Fi status helps us to know about the status of connection. Let's suppose it is not connected. Okay, suppose it is not connected. Uh, then if it is not connected and not equal to connected. Okay, let me put it in simple word. So if it is not connected, and so if it is not connected, then it will not be equal to connected, right? This suppose let's say it is equal to. Okay, so we write two equal tos to denote if it is while comparing we use two equal tos. While assigning we use single equal to. Okay, so let's say this is true. Then the dot will be printed only if the Wi-Fi is connected. Okay, so since it is not connected, uh, this loop will run. So in the starting, it will not be connected. It will take some time to connect. During that time, it will run this loop. So we have put this delay to, this delay will make the number of dots more or less. Okay. So if I increase the delay, like if I, let's say I decrease the delay, let's say 100, you can see more dots. Okay. Because it is spending the same, almost similar time here, but dot will be printed more times because due to the delay function being this small, less amount of time will be spent here, and it will move on to the like it will go to the top, and yeah. So as you can see, more dots are printed. It keep it at 700 or something to for convenience. So yeah, after this condition becomes false, if this condition whole condition becomes false, that is Wi-Fi becomes connected. Okay, this if this status becomes connected, this also let's assume it gets this value. Okay, so we have written a false statement, so it will never be here. Okay, so it will go down. This while loop won't be executed if we write this portion of the like we'll write it in this format. It won't stay in this part ever. So uh, so the status will be not connected initially. So this if it is not connected, this portion will be true. The whole line will be true if it is not connected. Yeah, Kshitij, yeah. Vastu, you can try it again. Okay, sometimes it takes time. to compile the program. You can try again. There might not be any mistake in your program. Still, it might take time. So yeah, has everyone done this? Is there any doubt? Yeah. Okay. So local IP. This function helps us to print the IP address. IP of the ESP32. IP address of the ESP32 in the network. Is everyone done with it? Hit a thumbs up. Nice, nice, nice. Guys, we'll be taking a break for 10 minutes. Fine. Uh, you guys need a break, right? So yeah, it's break time, guys. So we'll start by 11:50. Fine, right? Pranesh will take over.
Hello everyone. Is my voice audible and my screen visible? Give a thumbs up. Okay, cool, cool. Okay, shall we resume the session? Shall we? Like before the break, we saw how to connect ESP32 to Wi-Fi. After the session, after the break now, we are going to just see two components on how to connect with ESP32 and how to code using it. Okay, guys. In a microcontroller, the beauty of microcontroller is to use those pins. But in the first session, we have not used the pins, but now we'll play around with all the pins that ESP32 has to offer. Like uh, you saw how ESP32 looks, right? It has around 30 pins, like way more than Arduino. That's why we won't use Arduino initially because it is not beginner friendly. Since ESP32 has these many pins, like the people who get to start with microcontrollers would get scared because of these many pins and the complexities that is involved in ESP32. That's why even even if ESP32 is cheaper than Arduino, we won't use this. Okay, now let us get started with LCD display. You can know what LCD display is. Say what LCD display is. Do you have any idea? Just put it up in the chat. We'll see what LCD display is now. Okay, fine. Others? Nice, nice. I'm seeing a lot of answers. Liquid crystal display. Good, nice. Okay. Let me give a simple definition for what LCD display is. Like as you all said, it stands for liquid crystal display. It is a flat panel that uses liquid crystals to generate characters to display to us. That's it. That is LCD display. We have a lot of dimensions for LCD display. What we are going to see in this session is 16 into 2. What is 16 into 2 is, like we have 16 characters in a single row and we have two rows. So these many characters we can at a time show in the LCD display. That's what 16 times 2 stands for. Now you can see a lot of pins here, right? Like I didn't even got how many pins are there, but uh, these pins might look scary. These pins are very friendly to use. Like I'll say what are these pins stands for, and don't get confused because of these one description. Like once you start connecting using ESP32, you'll enjoy working with it. Like as you can see, all the devices that we use with Arduino or ESP32 has a ground and a supply voltage. These are two mandatory stuff that all the devices that we use have. And we have some different pins like RS. RS stands for register select, RW is read write, E is enable. These three pins are the main culprits which make LCD display scary. But after the session, it won't be that scary. It won't be scary, not that scary. It won't be scary. I'll explain the function of these three pins once we get into walkwe. And we have D0 to D7. We have totally 8 input pins to give input to our LCD display. And these two, A and K, stands is used for the backlit of the LCD display. The LCD display glows if we connect these two pins. If we didn't connect, then it doesn't glow. That's it. But even if we don't use these two pins, we can see the text that we're displaying. Let's straight away go to walkwe. Like these definitions are not that important. Let's go to walkwe and explore. Like the previous part, Okay. I think I got disconnected in between. Am I? Okay, now is it fine? Now is it fine? Now is it fine? Okay, where did I leave? Like, where did I get disconnected? Can you guys say where did I get disconnected? Okay, fine. Okay, in the previous part, Ajan said how to go to this page, right? Can you guys all come to this page and give me a thumbs up or put done in the chat box? Okay, nice. Has everyone come to this page? Everyone. Okay, cool. Okay, now let us pull out stuff that we need today. Like as you can see, there is a plus icon here, right? Near the run button. You click on that and just search for LCD. You'll see a lot of LCD displays coming up. LCD 16 times 2, 16 to I to C, 20 times 4, and 20 times 4 I to C. And these two are the things that you think we might be using in this session. But this I to C thing, what you see here, is for the third session that you'll see. So now we'll just be using this LCD 16 times 2. Just click on that. That will come to your page. And once you've taken this taken the LCD display out, give a thumbs up, and we'll start connecting. Okay, fine. I'm seeing a lot of thumbs up. Okay, let us start connecting. What we saw was the first pin is the ground pin, right? And the beauty with walkway is like once you click on that pin, you'll get the pin corresponds to the. Okay, fine. I will say how to add a LCD. I'll remove this. Just click on this plus icon that is here in blue color and just search for LCD. The thing that you see first is the LCD display to add. Is it cool? Okay, fine. Uh, Let me start the connections. When you click on the first pin, that is VSS, it stands for ground pin. Once you connect it, the walkway itself says to which pin of microcontroller should be connected to. Like as you can see, this white pin is highlighted. That is the ground pin. So you should connect it to this. Like that's what we saw in the pinouts as well. Now to maintain a color code, we'll make this. And the second one is VD. This stands for the power and get highlighted. The power red. Now we have this pin called V naught. We'll discuss this later. Like I'll explain this later. And this RS register select. I promise that I'll say what is the use of this register select once we go to walkway right. I'll say what is register select, read write, and enable this. Okay, inside LCD, like this is a bit theoretical part. But if you didn't get to understand what it is, that's perfectly fine because you don't need to understand everything that how it works. Like register select inside a LCD display, we totally have two registers. One is called command code register and another data register. A command code register allows us to send the command through LCD. Like if we want to clear stuff in LCD, if you want to print stuff in LCD, that is for command code register. And the data register that I said as the second register that allows us to send data to a display. Like what should we display to the LCD? And the first one is what should the LCD do with that data? These are two registers. So since we have two different actions for the registers inside a LCD, we can't just connect this to 0 or 1, because 0 corresponds to one register and 1 corresponds to another register. So we'll give it to a data pin. So the microcontroller will take care. Are you guys getting? Oops. Is my voice breaking again? Still. Okay, now is it fine? Hello, hello. Is it fine now? Okay. Okay, fine, fine. Today the internet is bad. I don't know why. Okay, let me explain what register select pin again is. Like inside the LCD, there are two registers that we need to select in order to put stuff inside LCD. So that the registers are command code register and data register. A command code register helps us to send commands to the LCD display, and the second one is used to send data that we need to display. Got it? Now the command code register, what it does is, like, it says the LCD to clear stuff or print stuff in it, but the data register is something that helps us to send data that need to be printed in the LCD. Are you guys getting the use of RS? I'm not doing anything on the screen right now, so there might not be a problem of lagging. I'm just saying what is the use of RS. Did you guys get what does this RS pin do? Okay, cool. Let us give this control of RS pin to the microcontroller that we use, because we don't know where to put this, because we are not that smart enough to get to put where the RS to ground or VCC at what time. So the microcontroller will take care. Now again, let us keep everything in different color. And now let us go to read and write. As the name suggests, this read and write pin helps us to read or write stuff. So now we are going to write thing in LCD, right? So in LCD, if we connect this read write pin to 0, it helps us to write, and if we connect it to 1, it helps us to read. This is the default setting of a LCD display. Don't ask me why. So we are going to write stuff in it. So we'll connect this to ground, because as I said, write corresponds to 0 and read corresponds to 1. And at the end, we'll play around with these pins. Like we'll put this read write to 1, read write to power, and we'll check whether it is displaying stuff or not. And now let us come to enable. Now same like register select, the enable pin controls the data transfer and synchronizes the timing of updates, ensuring communication between microcontroller and LCD. This enable pin helps the LCD display communicate with ESP32. That's the main use of this enable pin. So similar to register select, we don't know how to use this. So the microcontroller will take care. So we'll connect this also to a digital pin. Like make sure that you don't connect this to TX, RX. This stands for transmission receiving, and this comes to in communication part that we don't need now. Just connect it to digital pins like D5, D18, D19, D21. Got it? Is everything fine till now? Are you guys along with me? Okay, cool. Let us again change the color of this. So make it, now we have eight eight data inputs. Now let me explain the two types of data connections that LCD display has. It has 4-bit data connection and 8-bit data connection. We generally use 4-bit, but for now we'll use 4-bit, and I will explain how to use 8-bit data input as well. Like you see, 8 data pins. We'll just use 4 data pins to give stuff to display stuff in LCD display. And at the end of the session, if time permits, I'll explain how to use the 8-pin data input as well. But for now, let us use the 4-pin data input. For that, we'll use D4 to D7 pins, like these 4 pins. We'll connect these 4 pins to 4 data inputs, 4 digital pins. Like let me connect this to D18 and D5 to D19, D6 to D21, and D7 to D22. Or else let me connect this to D2. Okay. Is it fine till now? Like what I've done is I connected D4 to D7 to 4 digital pins. That's it. Once you guys done this, put a thumbs up so that we can proceed further. Once majority of you are along with me, I'll go for. Okay, cool. Many have done this. Now, as always, let's just because green color looks boring. Let's keep this green. Okay, fine. Now this A and K, as I said, the last two pins stands for the a backlight of the LED. Let us just leave this for now, and at the end we'll connect this. If we need the backlit. Okay, now let us go to the coding part. Okay. In the initial part of the session, Arjun explained about library, right? Even to use LCD display, we need a library called Liquid Crystal. This library offers us with a lot of functions that is used to display stuff on LCD. Let us see some of the functions that we have. Okay, okay. This is the library. You will import the library in this manner. Include liquid crystal.h, like as you saw that Wi-Fi thing, like Wi-Fi.h. Like it has a lot of functions. The functions that we will use in this session is lcd.begin. This function helps us to initialize the LCD or make the LCD work. This session, this function helps us to activate the number of columns or rows to display the characters, and this one clears everything and keeps our cursor in the starting position, and this helps us to change the cursor point. Like we have 16 pins, 16 characters in the first one, 16 in second row, right? Initially, the cursor will be in the first character, but using this, you can change the cursor. Like we'll see this also. And lcd.print. This is the function that we will use to print text on LCD. These are the four basic things that we'll use. And now let us start coding. Now let us include liquid crystal, liquid dot h. We have imported the library, and now we'll create an object for this library. Follow my code, liquid crystal, and we'll name the object LCD. And now inside the LCD, you will put totally 6 pins that we have given in control to the each with 32. Like what pins we are given to ESP32? We gave this register select, this enable, and the 4 data input pins, right? So we'll give this register select, enable, and the 4 data input pin numbers to to this data object, to this object. So let us see to which pin the register select has been connected to. It is D4. So you'll first start with 4, comma, and you'll do for enable. The enable is connected to 5. It is 5, and the 4 data pins. It's D4. It's 18. This might look time taking, but to display stuff in LCD, you should do this basically. And D6 is in 21, not 221. And D7 is in 2. Okay, fine. I'll repeat it. Until that time, those who got it, just make the complete till this code. Okay, fine. I'll explain the numbers again. Okay, this line stands for creating a object. So we name this LCD, and under this we'll put the numbers that we've given in control to the ESP32. Like as I said, we'll connect register select, enable, and the 4 input pins to ESP32, right? So we'll put this in order. Like I'll just write write this here, the order like how it should look like. Like it should look like LCD. Like this is just a comment, so don't worry. It should be register select, comma, enable, comma, D4, comma, D5, comma, D6, comma, D7. This should be the order in which we will be putting the numbers. Like the pin that register select is connected to. Like first, let's see register select. The yellow line, it is connected to D4. So in the place of register select, we'll put 4. And now let's go with enable. Enable pin is connected to fifth pin. So this is 5. And D4. D4 pin. This gray pin is connected to 18. So we have put 18 here. And let's see D5. This D5, this pink one, is connected to 21. So we'll put 21 here. And D7 is connected to second pin 2. So we have done like this. Did you get it? If everyone has done with this now naming the pins, do let me know. We'll proceed further in doing the coding part. This is the time taking process. After this, everything will be very fun to do. Wow, many very fast fingers, I guess. All have completed. Okay, let us remove everything that was initially there in void setup, and let us start coding. And since we have a object, we'll use that object to write functions here. That is lcd dot begin, like what we saw there. Like what this function does is you will put the column, the number of columns and the rows that we need to initialize. So we have totally 16 columns and 2 rows, right? We'll make everything work. 16 comma 2. What this line does is it will make the whole LCD work. Work in the sense it will say to work. It will give the command to work. Cool. Now let us go to the next line. Now let us start printing. LCD dot print. Let us put welcome. Fine. and that's it. Your code is done. It is looking funny, right? Like this big connections and LCD display just has 8 lines of code. To be honest, it has. Can you say this welcome thing here? That is it. You started displaying things on LCD. This is as simple as this. Are you guys also getting this welcome thing in your or the text that you put inside print? Isn't this fun to do? Okay, now let us see what this backlit does. Now let us connect this anode to high and this K cathode is CaThode, but here we have put K that corresponds to cathode. Let's change the color as well. And now let us run. What you can see, the background has lit right. To observe the change, let us remove this and see. Are you guys able to see the difference between the backlit and this?
Pranesh, your voice is not audible and it is fluctuating.
Okay. Hello, am I audible? Hello.
Yeah, now it's fine. Now it's fine.
Okay, fine. Is my voice clear? Hello, hello. Is my voice clear now? Okay, fine. Like, did I miss any important part, or it got? Can you repeat the last step? Like, which step? The backlit step. Are you asking about? Yeah, fine. Like that is nothing but the last two pins that I said we'll talk about later. Like these two pins, we'll connect this to anode and cathode. Like what is A and K stands for is anode and cathode. Okay, guys, if my voice is not a voice is not clearly audible, do tell in the chat so that I can repeat. Okay, I'll connect this pin to anode. Like that's how we should connect in order to lit the LED. So let us maintain the color code. And now let us start simulating. And the back is lit. That's it. Not a big deal. Is it fine? Yeah. After running the code, directly will come written. Yeah. Like what you generate done. Like let us decode what you written in the code. Like we have initialized the object. inside object we put what all connections that we have given in hands of the microcontroller, and after that we made the LCD display to start, and it started, and we'll start giving commands like we'll say LCD to print something, and it prints. That's it. It is as simple as this. There's nothing big or fancy to do for LCD display. It is very simple. It's the use of library like crystal library.
Pranesh's voice is getting
16
stuck.
means the number form. Again, like I'll leave and come again. Hello, hello. Is it fine now? Hello. I changed the network. Now is it fine? Is it fine now? Okay. Like sorry for the inconvenience, guys. Okay. Now we are just using a single line, right? Now let us use the second line as well, and let us print. And I'll explain why we are putting this in the void setup and the next thing in the void loop. Like inside the void loop, since we are here, we need to use the second row's first element. We'll change the cursor point. Like for cursor point, we saw a function called set cursor, right? Now we'll use that lcd dot set cursor. Now inside set cursor, you'll give the number 0 comma 1. Now I'll explain what is 0 comma 1. Like the first one, 0 stands for the nth character of the row, and the second one stands for the number row, like which row we are going to print stuff. Now we are going to print in second row, right? Then you might be thinking there should be 2 here, but for any coding language the counting starts from 0, not 1. So this is a 0th row, and the next row is the first row, or the 1th row, as you can say. So this is 1, and 0 stands for the first. And now using this, you'll make the cursor come to the first element of the second row, and you can start printing. Like similarly, lcd dot print, like as you did. I put hello. Are you guys still here? Are you guys getting what you've done? If you have any doubt, do put in the chat. Did you guys understand what is happening? Is my voice still breaking, or it is fine? Yeah, sure. I'll set cursor again. Okay, what set cursor basically does is it changes the cursor position. Like as you can see here, let us forget about the LCD display. You can see a cursor here in the 17th line, right? We can change this cursor position. Like I can change this to here. I pressed control space and I made it here. Like similarly, inside this LCD display, you can change the cursor point to a point to a point that we desire using this function. So the cursor inside the inputs that we give is the first element is the character in that row in which the cursor should be in, and the second one is which row the cursor should be in, and 0 corresponds to the first character. Since we know that for any coding language, the numbering starts from 0, not from 1. So 0 stands for the first character and 1 stands for the second row, because the first row is called the 0th row and this is the second row is called the 1th row. So in this way, we will set this here. Like once we run, you will understand why. Now let us run this. Are you getting this? Like we got hello in the second line and welcome in the first. Are you guys also getting the same? Nice, nice. Do you have any doubt in the function that we are using? Now I'll explain why we are putting this welcome in setup and the hello in this. All good, right? Till now, if you guys are along with me, do give a thumbs up so that we can proceed further. Come on, guys, I'm not getting a lot of thumbs up. Still. Okay, good. Okay. Now let us put this welcome inside the void loop. Let's see what happens. I'll cut this Control X and I'll paste this here. Control V. Many would be expecting to do this, right? But we unexpectedly put this welcome there. Now let us run this and see what is happening. This should work fine, in all our opinion. Huh. Can you see what is happening here? We got a welcome and a hello and again a welcome. Can anyone say in chat why is this happening? Let me see. Like it is very simple to break down why this is happening. Awesome. Since we put this welcome in the void loop, what this function first does is it first prints welcome in the first row, and now the cursor position is changed, and we have printed hello, and we're again going to the loop, but now the cursor position is in the same position that we have left, like after the hello. So it has printed welcome after this hello. Are you getting? Nice, good. So if you want to print something in the second row, we'll put the things in the first row inside the void setup. And now it works fine. Cool, right? Is everything fine? And now let me explain what to do with these 4 pins. What I said initially was we have 4-bit data transfer and 8-bit data transfer. If we use these 4 pins along with these 4, that becomes a 8-bit data transfer. Using a 8-bit data transfer, you can do nothing much, but you can increase the speed of the data transfers. Like the data that we send through this code, the speed of LCD display printing it increases. That's it. Like the microcontroller has a lot of data inputs, so it can give the entire message in one or two iterations, and it can print the thing there. Yeah, we can put both in setup. That's also fine. And this is the major difference between 8-bit data transfer and a 4-bit data transfer. Like if you want, you can connect this D0, D1, D2, D3 to 4 more digital pins. Because we are not scarce of digital pins since it's ESP32, it totally has around 40 pins if I'm not wrong. So you can connect to as many pins as you want. But already we have connected 6 data pins. So in order to save the number of digital pins, even compromising with the speed, we will use 4 data pins to store information. That's not a problem. Is everything fine with LCD display? I am sure no one would be expecting LCD to be this simple. Okay, nice. Do you guys have any doubt? Can we proceed further? Okay, sure. I'll explain 0, comma 1 again. Okay, let me go to the set cursor that we have in our presentation. Like what is set cursor? The gets as input is it gets the column number and the row number. It gets the column number and the row number, and to that position, to that particular position, we'll get the cursor. Like what I put is 0, comma 1. What the 0, comma 1 does is the 0, comma 1 sets the cursor to the 0th position of a row. And what row is it? It is the 1th row. Like 1th row here stands for the second row because the counting starts from 0. That's it. Satvik, yes, we can print a changing data. Like what you're saying, that is uh, the scrolling data that goes through this LCD display. Are you talking about that or something else? Yeah, Harshini, the main difference between 8-bit and 4-bit is the speed of data transfer. That's it. Like now itself, you can connect this D0, D1, and D3 to 4 digital pins, and you can add this in an order such that here, as I mentioned in the comment, you can put D0, D1, D3 before the four data inputs that we have used. Like the only difference here is the speed of data transfer between the ESP32 and the LCD. There's no big difference. Okay, is everything fine? Okay, real time changing data. Yeah, we can put that also. Real time changing data. Like once I remember doing a project using a device called MPU6050. You guys might have known it, but if you don't know, it is not a problem. That is not needed for now. Like that device changes That device changes a real time changing data it has, like it is fixed in a car, and the car's acceleration it determines, and using that we can print it inside the LCD display, not a problem. Okay, fine. We hardly have 30 minutes left, so we need to cover the sound segment display as well. So let us go to sound segment display. Now, if you have any more doubts regarding LCD display, you can DM any of our admins in the group. We'll answer. Now let's go to sound segment display. Okay, I have attached the code as well. You can copy if you want. Okay, let us go to sound segment display. Now, a sound segment display is a display that uses 7 glowing segments to represent digits or some characters using the sound segments available. You can change the glowing pattern of these sound segments, and you can make some different characters using these. This is the major use of the sound segment display, and the pins that you can see here, like it has A, B, C, D, E, F, and G in random order. Like these pins corresponds to the segments that it's named. Like if we use the A segment, you can control the lighting of A, B segment for B, similarly for all others. And the common pin that you can see here is either connected to cathode or anode. And the pin called DP stands for decimal point. You can have a series of sound segment displays, and you can show a decimal point as well. Is the definition of sound segment display clear? Like how it works? Like this is how it works. Using these pins, you'll control this, and we'll do this in walkie. Now, is it fine? Do give a thumbs up if we can go to walkway now. Okay, let us now go to a new walkway, and let us use the same ESP32. Because we are not children anymore, we won't use Arduino. Now similarly, like using this plus icon, you will get the sound segment display. As you can see, there's sound segment display. You can take the sound segment display out. Are you guys still here? Did you guys took the sound segment display out from the walkway? Everyone? Okay, fine. Okay, now like I'll expect you guys to take out a pen or some notes in your mobile in order to note down the pins that we're connecting to, because last time we connected the RS enabled to some random digital pins, and we kept on tracing back the wires that are connected, right? Now we'll just write down the pins that A is connected to. If A is connected to 21, we'll write A21 in that, so while coding we can do it fastly. Is it fine? Because if we trace back every time, then it takes time. In order to save time, let's do this. Okay, fine. Let's proceed. Let us start with the common. As you can see here, we have two commons, right? So connecting one common is sufficient. It is not like one is for ground and one is for power. Like don't misunderstand like that. I'll explain why we are connecting this to power and not to ground and everything else in a short while, and we'll maintain the color code. Like, don't get super curious and ask in the chat like why we are doing this, why we are doing that. We have explanation for that too. And now let us start connecting this. I'll connect this A pin to D23 and I'll write this A as 23 in the note I have. And this B pin, let's connect this to 22. B pin is 22. And we have this F. Okay. F, let us connect it to 21. F is 21. And G. G is 19. Okay. I am connecting these. Are you guys connected this four? Did you guys connect these 4 pins? Like, I'll change the color as well. Done connecting these 4. Fine till now. Like, it's not necessary to connect to these 4 digital pins. You can connect to any digital pin. Make sure that you don't change the numbering. That's it. Like, if you change the pin number, you change it in the code as well. Fine till now. If you guys are done with these 4 pins, do let me know. I'll proceed further. Very less thumbs up. Nice, nice, nice. Okay, let us proceed further. I'll take this E pin, I'll connect it to D2 and this D pin. Wait, let me note it. I forgot to note. D pin to second. And this is, oh, this is E. E to second. And D pin to 4. And what we are left with finally C. C is for 15. Fine. Now we have connected all 7 segments and we will not be using this decimal point again. So leave it. And this common also we won't be using. Or else you can connect this you can remove this anode, and connect the other side to anode to VCC. That is also fine. Now again. If you guys are done with this, give some thumbs up so we can go to the coding part now. Everyone, till now what we've done is we just made connections between the segment pins and the microcontroller. Okay, everyone done, I guess. Okay, let us go to the coding part. Let's make some space. And now we'll start assigning variables to A, B, C, D. Now let us put int of A equals like the number of the pin that you connected to. I connected this to 23. And similarly do this for all the 7 segments. Like the LCD display, the initial part here is like a bit time taking, but finally it's worth it. I'll give time after I've completed, so don't worry. In this way, we will initialize all the 7 and we'll make corresponding segments glow. Like I'll say how to do it. Like once you guys have done this, give a thumbs up or put done in chat. I'll wait for a few minutes so that we can go along. Nice, nice. Good. Okay, fine. I think many of you have done. Now let me go to the next part. Now, do you guys remember what function we used to make the LED glow? Like not a digital right thing. Like what we made to give it as output. The output function that we've used. Good. Yeah, pin mode. No, not the LCD. The blinking LED in the last session. LED. Uh, yeah, it is pin mode. Now, since we have sound segments here with us, we need to do this for sound segments. So, which is very time taking. Like what I am coming to say is, like you will use pin mode of A comma output, B comma output, C comma output. This again increases seven more lines, right? So for that, we'll use for loop. Like I'll say how to use a for loop. Before that, uh, okay, I'll say how to use a for loop for integer I equals 0, I initialize 0, I is less than 7. Like totally we have 7 segments, right? So we'll use I less than 7 and I plus plus. So what this I plus plus says is we are increasing the step by 1. And now we'll use our pin mode function. Pin mode of, we need something to iterate, right? Like we need A comma output, B comma output, C comma output. Like to make that, we need array. For that array, I'll put pins. And if you don't know how to initialize an array in C++, just it is a step Google away from you. You can find that anytime. Like what this 7 says is it has 7 elements in it. So you can't change the size of array in C++ language. Like many of you know Python, right? Like in that Python you can change the size of the array, but in C++ you can't. So now I'll put pins of I and I'll give output. Okay, now what this pins I does is initially if I is 0, it will put I 0 and the first element A is A will come here and A comma output, and similarly B comma output, C comma output. You'll have 7 iterations in just single line. Are you getting this? If you guys are still here, do tell me, we can proceed. Oh, many thumbs up. Are you guys really doing with me, or are you just giving thumbs up to proceed? Okay, we'll continue. And now let us now run the program and see if we have any errors till now. Okay, it's working fine. Like we didn't get any error. Now let us go to this void loop thing, and let us start playing with digital, right? Digital, right? Let us put a comma I. Like what we expect is the a pin to go, right? Because a comma high says a pin and high says to glow or light up, right? Okay, let us run this. No, once again I'll explain how this for loop works. Like for, like if you write the condition in the same line, you no need the curly bracket. Like I'll add the curly bracket for you, and now let me put a curly bracket here and run this. It works fine again. Like this is how for loop works. Like if you put the statement in the same line, you no need curly bracket. If you put it in the next line, you need a curly bracket. That's it. Swati, did you get it? How this for loop works? Okay, let us see what is happening. Okay, what we've done is digital write of a comma high, and we expected the a pin to glow and the others to not glow. But what are you observing here? You're seeing the a pin is not glowing and all other pins are glowing. Okay, something interesting happening. Do you guys have any idea what's happening? Like anyone? Like no one expected this output, right? Like at least me, when I did this the first time, I didn't expect this to happen. Change the common pin, active low nice. Because common is connected to power. Common cathode sun segment. Good. Like many are, you're very closer, many of you guys. Okay, to understand what is happening here, let me introduce you to two types of sound segment displays that we have with our in our market. We have a common anode sound segment display and a common cathode sound segment display. Okay, what a common anode sound segment display is, I'll explain. A common anode sound segment display is these are the segments as you can see in the monitor. These are the segments that we have A, B, C, D, E. These are basically you can say LEDs or light emitting diodes that have one side is connected to that common pin and the other side is grounded. Like this is a feature of a common sound segment anode. Common anode sound segment display. Okay, what we have in our control, which one we are giving the microcontroller control is this these grounded pins. Since for common anode sound segment display you connected this common pin to anode, so this is in high, right? The common pin is high, so one side of common pin is high and the second pin of and the other side of the common other side of the LED is grounded. So once we gave pin mode come output, it started glowing. Did you guys observe in the first place? Like I'll remove this and I'll run. As soon as we gave, all the pins started glowing. If you guys have observed this, you would have got a doubt why all are glowing. We didn't give the high command, right? Now let me say why this is happening. And now I have given a comma high, right? Now this grounded pin becomes high, so the voltage difference between this a segment becomes zero. That's why it is not glowing, and the remaining pins have one side high and one side grounded. Are you getting why one side is glowing and the other is not? Like very interesting, right? Okay, sure. I'll repeat it once again. This is not a thing that you can get it in the first time itself. Okay, this is how a sound segment display looks from inside. From inside, one side of the segment is connected to the common, and the other side is generally grounded. And the other side is what we will be controlling using the microcontroller. So this is common anode sound segment display. How it works? In this common anode sound segment display, we will be controlling the ground part. We have connected the a common to anode. So one side will be high always it is high, and the other side is grounded generally. Like before we give any commands, it is generally grounded. If we give a comma high, what it does is it changes this ground, and it gives high here also. So the voltage difference between this segment becomes zero, and the current doesn't flow through it, and it turns off. Is it fine? Like for LED to glow, we need a voltage difference between its two ends, right? So here the voltage difference becomes zero. That is why it is not glowing. Fine. I guess it is. Now if after the session you can go to Tinkercad and see. There you have a common anode sound segment display and a common cathode sound segment display as well. There you can play around. There you can see that common cathode sound segment display. If you give a comma high, only at that time it becomes high, and all of the times it doesn't glow. And in walkway we don't have common cathode, we have only common anode. That's why it works in this way. Is it fine? Did you guys understand what is happening right now? Interesting, right? Okay, let us start printing some numbers now. Now let us go to this again, and let us start printing some numbers. Now let us print 0. To print 0, what we need is we need this middle one to not glow. So to not glow, especially in this 7 segment display, since it is common anode, what we should give is digital right of G comma high. Now if we run this, uh, we are getting 0, aren't we? And okay, let us print some other number, like say a number, like let us say 1. Not 1, let us print uh, let us say 4. To print 4, like you can visualize which segments to glow and which not to glow, right? And let us look at that. These are this is just a outline to which segments to glow and which not to glow. It is A, D, E, right? So we should give high for A, D, and E. Now let us again go to walkway and give high. Like again, you will do like you will write digital right of A comma high and D comma high and E comma high. In that way, you will increase number of code and the complexity increases again. So let us not do that, and we'll again use a for loop. And while printing numbers, for loop will become very handy for you guys once you start practicing printing numbers in a 7 segment display. Like again, let us put integer j equals 0, and the number of pins that we need to give is 3. So less than 3, a plus plus. And now I'll give digital right of something like similar to what we did for pin mode. We'll give a array like what we're going to print 4, right? 4 of the total elements inside the 4 is 3, because we are going to turn off three LEDs. And what are the LEDs? It is A, D, and E. I'm not wrong. Now what we'll give? It is 4 comma J comma high. Are you getting how did we write this code? This line to print 4. Once you guys reach till here, say we can proceed for other numbers as well. Do you guys have any doubt till now? Okay, I'll repeat the loop part once again. Okay, this loop part. Okay, what I've basically done is, like, if you know for loop, how for loop works here, like initially this for loop goes through j equals 0, j equals 1, and j equals 2. Since we have put a upper bound that j is less than 3, so it iterates 3 times. Now we are given digital right, or I'll write it in the standard way. Like for loop, many do understand in this way. Okay, here inside for loop we have given 4 of j. Like what is 4? 4 is the array which has 3 elements a, d, e. What is this a, d, e? These are the segments that we don't need to glow, that we don't need to glow, so that we'll get the number 4. Now 4 of j, what it does is, first j equals 0, 4 of j is 4 of 0, 4 of 0 is a becomes high, high means here it turns off. And similarly d for j equals 1, and e for j equals 2. Did you get it? There is a module. Okay, fine. Like I am not aware of that module. If usually we do it this way. If you guys need, you can explore more on this. Like this is a vast ocean. Now let us run this. We got the number 4. Nice, right? Do you guys have any doubt in this LCD part as well as this sound segment display part? If you have, do put it in the chat. And there's a good news for you guys. After this session, we'll be giving just one task, because we have our next session in a day after tomorrow. So I hope you guys won't be getting time to do tasks. Like since it was a weekend last time, we gave 2 tasks. So this time we'll give one task, and that too won't be that time taking. So yeah, you'll get one task after this session. Can we use this thing also in similar way? Yeah, you can use, but I'm not sure what are the pinouts of that sound segment display is. Let me see. Okay, it has quite a more number of sound segment displays. So for this, you need to learn out the pinouts as well. So once you do that, you can. Okay, guys, don't leave. Like we need to download the attendance report as well. Okay, is everything fine? Like this time we have managed to complete the session at one. That is a good thing. Once again, guys, I think some doubts are coming. I'll again share my screen. Sorry. Uh, okay. Attendance will give the Google form as well, and we'll and I've downloaded the attendance sheet that is provided by Teams, and we'll see how much time, how much people have stayed. Like why 4 comma J I in digital, right? Sorry, I'm not getting. Like 4 of J. Okay, why we are using digital right here? That's what you're asking. Wait, I'm not getting it out. Okay, what is this a 4 of J? Okay, what is this 4 of J does? Like I'll say what this 4 is first. Like this 4 is just an array that has three elements in it: A, D, and E. What is A, D, and E? A, D, and E corresponds to the segments A segment, D segment, and E segment. Are you getting this? And after this, 4 of J, what it does is if I put 4 of 1 or 4 of 2, that is the one element or the second element of this. If I put 4 of 2, that is the third element because the counting starts from 0. So in that manner, if this loop runs, let us say j equals 0 initially, and it will becomes 4 of 0. Like what is 4 of 0? The first element of the array 4. It is a. A, A, A comes here instead of 4 of 0, and it becomes digital right A comma high, and it turns off A segment. And now we put J plus plus. What it does is it will increment J by 1. So it will become J equals 1 now. Now 4 of J, 4 of 1. It will become 4 of 1. What is 4 of 1? 4 of 1 is D. It will become D comma high. In that way, D segment turns off. Similarly for A. And now since the upper bound is 3, it will go only till 2. 0, 1, and 2. In that way, we can make the three segments off. Is it fine? Like this is the working of for loop in C++. Okay, fine. Okay, is everything fine? Yeah. As of now, the session is officially over.
Yeah, so we'll be circulating a G form, okay, to fill in your attendance. Thanks for attending the session. We had really a lot of fun. Thank you, guys.
Yeah, thank you guys. You can start leaving now.